Yeah, dear students, I would like to start the class from where we concluded, yesterday. So today, what we are going to discuss is to find the conditions for a quadratic equation to have a repeated root. Okay. Second one is that the condition for two quadratic equations to have a common root. Third one is that conditions for two quadratic equations to have same roots. Okay. So what are the different possibilities can happen? So let us first concentrate on that. So let us consider quadratic equation. You know that quadratic equation, we can write something like this, that ax square plus bx plus c is equal to 0. Now how many roots it has? It has two roots, alpha and beta. Now we are going to find conditions that what should be the condition followed by the different expression making out of ABC, the coefficients and the constant term, so that alpha equal to beta have a repeated root. Second one is that this in this quadratic equation, okay, we get the same root alpha two times it is coming. That is the first case. Second case is that, dear students, is that we have two quadratic equations. Suppose the first quadratic equation is that a1 x square plus b1x plus c1 is equal to 0. And the second one is that second quadratic equation is that a2x square plus b2x plus c2 equal to 0. Now if you look into the first quadratic equation, dear students, so its roots could be alpha 1 beta 1, and its roots could be alpha 2 beta 2, the second quadratic equation. Now we are going to discuss that under what condition we'll find that one root, okay, between alpha 1 beta 1 alpha 2 beta 2 will be the same. That means as if we get the roots of these equations are alpha 1 beta alpha 2, kind of this thing. Or we can say the roots of these equations are alpha beta and alpha gamma. Means one root is common. And the second case what we are going to discuss is that when both the roots are common. That means the first equation has roots alpha beta and the second equation also has roots alpha beta. These are the points what we are going to discuss today. So let me bring the relevant topic. Okay. Now, can someone please tell me, if you recall, that under what condition a quadratic equation like ax square plus bx plus c equal to 0 have a repeated root, or both the roots are same? Under what condition?
When d is 0.
Fantastic. Appreciate. When discriminant is 0. Absolutely correct. When we say the discriminant is 0, we can say this thing. Absolutely correct. Thank you very much. Now, there is another way also we can look into the same problem. Okay, how we can look into it? Let us assume that the root alpha of the quadratic equation will be repeated. Under what condition? If alpha is a root to this equation, under what condition alpha be the another root? Okay, slightly different way I made the statement, but the intent remains the same. So here what we say is that if alpha is a root of the quadratic equation ax square plus bx plus c equal to 0, then alpha will be a repeated root if both the conditions are true. The first condition, dear students, that if alpha has to be equal to 0, and the second one is that f dash alpha has to be equal to 0. What is f dash alpha? F dash alpha is the differential coefficient of fx, and after that you are applying x equal to alpha. So that means if I elaborate this points little more, we know that fx equal to what? Fx equal to ax square plus bx plus c equal to 0. So now, as alpha is a root, definitely f alpha has to be 0. That is quite sure. Because alpha is the root, it must satisfy the equation. So if alpha is equal to 0. So there is nothing new in this condition 1. It is so obvious. Now what is f dash x, dear students? If you recall our differential calculus classes, it should be 2ax plus b, correct, no, dear students? So that implies what? F dash alpha, that is equal to what? 2a alpha plus b, that should also has to be 0. If alpha equal to 0, whenever I say, dear students, that is equal to a into alpha square plus b into alpha plus c has to be 0. That is the first one. And the second one is that f dash alpha, that is 2a alpha plus b, that should also be equal to 0. These are the two conditions has to be satisfied. So now another approach, as you correctly said, Sagnik, is that d has to be equal to 0. That is also true. That also you can apply. But this is more convenient if you use the differential calculus. Now the next point, dear students, what I'm going to discuss is that I already gave a brief overview when we are dealing with two quadratic equations. Okay, what is that? So conditions for two quadratic equations to have a common root. Okay, and also we'll find what is the common root. So if you look into it, dear students, that what we are going to discuss is that conditions for two quadratic equations to have a common root. So what are the two equations here, dear students? One equation is a1x square plus b1x plus c1 equal to 0. And the other equation is that a2x square plus b2x plus c2 equal to 0. These are the two quadratic equations. Now, these two quadratic equations to have a common root, that means what? That means is that if the roots of this equation, the first equation roots are, for example, a1x square plus b1x plus c1 is equal to 0 if its roots are alpha and beta, then the other equation a2x square plus b2x plus c2 equal to 0, its one root will be beta and another root will be gamma. That means beta is the root which is common to both the quadratic equations, dear students. Now, under what conditions this has to be satisfied? The condition 1 is that a1b2 minus a2b1 has to be not equal to 0. And the second one is that a1c2 minus a2c1 square is equal to b1c2 minus b2c1 into a1b2 minus a2b1. That is the second condition. And that also has to be true. See, both the conditions hold true. We can conclude, yes, both the quadratic equations, that is a1x square plus b1x plus c1 equal to 0 and a2x square plus b2x plus c2 equal to 0, have one common root. Now, what is that common root? Means what is that beta? The common root is that a1c2 minus a2c1 divided by a2b1 minus a1b2. So, if you see, dear students, here all the things we are finding with the coefficients in the constant term. What are the coefficient? a1, b1, a2, b2 and constant terms c1 and c2. With these only we found this, conditions which is required for two quadratic equations to have a common root. And what is your task? Your task is to memorize these conditions. If you memorize it well, then you will see that how efficiently you are able to finding the solution. And the consequences is that if you do not memorize it well, that doesn't mean that you cannot solve that one, but it will take relatively longer time to solve. Now, the next condition, dear students, what I would like to discuss is that conditions for two quadratic equations to have same roots. And here the condition is, quite straightforward. As if, look like that, you know, they represent the, similar kind of curve, isn't it? One is a multiple of the other. Absolutely. Means all the coefficients are multiple of the other. So, what are the conditions here? So, apparently, it looks like that what kind of statement it is, sir? That both the quadratic equations to have the same root, as if both are same quadratic equations. Apparently, it looks like. So, what is this? Here you see that a1x square plus b1x plus c1 equal to 0. So, what are the roots of this quadratic equation? The roots of these quadratic equations are alpha and beta. Now, we are telling, no, we have another quadratic equation, that is a2x square plus b2x plus c2 equal to 0. Its roots are also alpha and beta. Under what condition it can satisfy? The condition is that the coefficient of x square, coefficient of x, and the constant term should be in proportion. That means a1 by a2 should be equal to b1 by b2 should be equal to c1 by c2. We will discuss all these things in details, dear students, when we will discuss parabola. As I said in one of my previous class, that this quadratic function, it actually represents a parabola. So if we give a geometrical interpretation of these, equations, so it leads to a parabola. So when we will discuss about parabola, we'll again come back to all this, and you'll find it is, so, interesting again. Another point, dear students, that is the last point for today, and that is what is a general expression of second degree? Okay, general expression of second degree is in two variables is an expression something like this, that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. Let me write it down. Then explain you a little bit so that you get a clear idea about the general equation of second degree. Then detailed discussion we will be doing when we will discuss about conic section and including circle. So dear students, what is the general expression of second degree in two variables? It is generally denoted as ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is a general expression, so I should not use that 0. 0 is not required. So this is a general expression of second degree in two variables. Now, we can express it as a product of two linear factors, correct or not? So for example, this we can write is that a1x plus b1y plus c1 into a2x plus b2y plus c2. It is not true that always we can do this thing. That means a general expression of second degree in two variables is not always possible to express as a product of two linear factors. Under what condition we can do this? And that we are going to learn now. The condition to be satisfied that a general expression of second degree to be resolved into two linear factors, that you know a value of the determinant, I'm just going to show it to you, the value of that determinant has to be equal to 0. So dear students, so this is the underlying condition, that a general expression of second degree like ax square plus 2hxy plus by square plus 2gx plus 2fy plus c can be resolved into linear factors. The value of this determinant, you know, is a 3 by 3, determinant, determinant of order 3, has to be 0. But now, how to write this determinant, that I'm going to show you now. So the best way to write is that first keep this thing. Then first you write the, A, B, C. Then you write F, G, H, and in the same manner, F, G, H. That as if that if you keep a mirror along that ABC of the diagonal, if the whatever you see that, if you keep a mirror along this, whatever you see, H, G, F, you will get a replica here. Correct, dear students? So the simple way what I'm saying is that to write the determinant is that, let me write in a different color once more so that you can remember, because this is what is important. The style of writing is also very important. You should write something like this: A, B, C. Then you write F, G, H, F, G, H. And that value has to be equal to 0 in order to have the expression which is a general expression of second degree, like ax square plus 2hxy plus by square plus 2gx plus 2fy plus c, to be resolved into two linear factors. With this, I would like to conclude the class for today. Tomorrow, we will be discussing, that inequalities on real quadratic expressions, and you will find it very interesting. Okay, if you have any question, please feel free to me. Otherwise, we will conclude the class for today.
Sir, I was doing DPP set 7 yesterday,
Okay.
and there were many questions on locus of circle and the equation representing a circle and all of that.
Okay.
And I
So
did.
thanks for your question. So what I'll do is that, yeah, certainly, these are the questions at this moment you cannot do. But dear students, so what I'll do is that I will send you one of my previous class YouTube lecture, which is available on locus. It is, students say it is a great lecture on locus. So I'll send you, and please have a look into it. So,
Yes.
for example, you can do in this way. If you just give me a minute, I can explain you, just how to look into it. So let me stop sharing this screen and let me share another screen, which is in which you can look into it. So let me stop presenting this one, and let me. You just go to Google, and I'm just going to give this one. There are two ways you can do. Those who are subscribed to my YouTube channel, that is one. You able to view this page?
Yes, sir.
Okay. So those who are subscribed to my channel, then to perfectly fine. But otherwise, what you can do, you can just write KonarClasses locus. Okay. So then you'll find. You see the first one.
Mm.
You can just look into this one. This is one way of looking into it. Now let's join these 2 points and this center. Then what is CP? CP is nothing but 5 units according to the question. So what we can write? We can write CP is equal to 5. So you got it, no, dear students?
Yes.
Yeah, so that you can look into it. Means, but if you subscribe to my channel, then no problem. So then, always you can look into it. Otherwise, you go to YouTube, write KonarClasses and any topic. For example, for say, if you want to know, it is in YouTube. You give KonarClasses. You give differential calculus. Yeah, you'll get a series of sessions. Session 1, session 4, session 6, all these things, session 2, all these things you'll be able to get it. Okay. So you give, KonarClasses binomial theorem. You'll get the binomial theorem related all these sessions. Okay. And it is
Okay.
very categorical. It is mentioned here. Okay, so please like this, go to KonarClasses and give Lokash, then you will get it. And then if you have any doubt, we can discuss always. Okay.
Yes. Thank you.
All right. Thank you very much. We will again have our class tomorrow.
Thank you.
All right.